beginning this afternoon with variables and conditionals are two big topics. I've just put together a basic file to illustrate a few points, then we're going to construct something a little bit different. But this gets across a few of the key concepts. So if we run this file and look at it, what it does is it comes up, it draws two lines. So we can see the 4 quadrants on the screen. If I move my mouse into each quadrant, what it's doing is it is now checking where is my mouse currently at. It's looking at both the X and Y position of the mouse, and then it is displaying a different color based on that information. So things that are happening here is I am drawing an ellipse, a circle, at a set of coordinates and at a specific width and height based on the values that I have currently set. So what this does is we could just type in our ellipse and say ellipse at 300, 200, 50, 50, and it would draw my circle at that point. But the advantage of using a variable to store that information is now if I want to change it, it becomes a pretty straightforward operation to do so. So if I wanted the circle to be at a different location, all I have to do is set X or Y to a new value. And as our projects grow in complexity, we're going to have lots of objects on screen. And they're going to have self-changing values, so they will be animating or moving of their own accord. And in doing so, we don't want to have to 60 times a second try to figure out, well, what is it supposed to be? We just need a way of storing that information, of storing the size and position, or also in this case, the color of the objects that we're working with on screen. So if you notice, I have some values up here. And the way that we define variables is we have to give them a name. In this case, my variables are X, Y, W, H, and C. Now, sometimes we need variable names to be long and verbose so that we can make sense out of what it is. Other times, when they're representing something that's fairly common, X and Y being location, WH being width and height, we don't really have to spell those out. We can just say X, Y, WH. Now, if we have different objects that we need to keep track of, we may have ball X, or box X, or shark X, shark Y, person X, person Y. So we'll have these different values, and we'd have to define them with a little bit more of a name. But right now, if I only have one thing, it's easy to just do X, Y, WH. Color, well, see, that works out well for color. So when we name variables, we just want to use something that makes sense. I don't want to name my variables based on just random things. So when I look at the code, it's like, what is that? It just doesn't make your code readable. So you want the names to try to make your code more readable instead of incoherent and only readable by you. Now, when I see the word float next to it, one thing that happens in processing when you're working with variables is you have to specify what kind of variable it is. And in its simplest way of thinking about it, a variable is just a way to reference and store a value. That value can be a letter, such as a character, like the letter A on my keyboard. It could be a word, such as a name. It could be a sentence, multiple words strung together. And then a variable of that type we refer to as a string. It's a string of characters grouped together. And then we have different kinds of numbers that we can work with. We have floats and we have integers. Now, integers are whole numbers. They can be positive or negative, but they are whole numbers. So 1, 2, 3, 4, 5, -1, 2, -2, -3, -4, 0. These are all whole numbers, which are different than floats, because floats are allowed to have a fractional component or something after a decimal point. So when you're working and doing your code, if you're trying to decide between float and integer, generally just call it a float, and that will work for more situations, because integers aren't allowed to have anything after that decimal point, so they're only whole numbers. Where we could have 3.14159 and continue it all out to infinity, and then that becomes pi. But we could also have 2.65, 1.32, 1.99. These are all float numbers because they have a floating point in them of that decimal. So if you just assume floats get to have fractional or something after the decimal point, integers are whole numbers and there's no fractional point. Use float when you want to number. If we wanted to reference a character, we can do that. Or if we want to use words strung together, we use string. Now string is capitalized. We'll worry about that down the road. That doesn't matter. We're not doing words right now on this project, so just know that string is capitalized. All the other data types generally aren't. But it's important to reference what type of object or variable is going to be, because then processing can allocate or set aside a little piece of memory and say, for this thing, I need X amount of space to store that object. So that's why processing requires you to specify what kind of data type it is. Now, some languages, like say JavaScript, we just type in the word var, and then we just say var my variable like that. And everything is just a var. JavaScript doesn't care what type it is. It figures it out along the way. But not most, but a lot of programming languages require you to specify when you're declaring a variable, what kind of variable is it? What's it going to hold or contain? But a variable is just, it's a container that holds a reference to something. A value, a word, a string, a number, an object. It's just a reference to that, and it's a way to then refer to it in our code in a much more concise manner. Now, sometimes the question comes up on, well, what should I make a variable and what should I not make a variable? At the end of the day, making more variables versus less is not going to hurt you, and usually is going to be a better operation. Some people say every number that would show up in your code somewhere should be referenced as a variable, not as an actual number inside the lines of code. So you store every number that your program uses in a variable, even if it's only used once. But if you're going to use something more than once, then it would make sense to refer to it as a variable. So if I were to say something like, x plus 5, come on, and try again, plus, whoa, it's misbehaving there. So if I were to add 5, so if I'm adding the same thing twice, and that's representing the same. So if that's a value, it would make more sense if I wanted that to maybe say, maybe that's an offset. So I want to offset it. And then go define what offset is. So then say offset is equal to 5. Now when I run it, now we can see it's off by 5. But the advantage of doing it this way is now if I say, well, I want offset to be 50. Well, I just change it once here, and now it changed both values. So when we're using variables, it's something that the more we use them, the more flexible your code becomes. If you don't use variables and you hard code everything with strict numbers, if you want to update or change anything, it becomes increasingly hard and difficult to do so. So if we think about previously, we were drawing things, say, based on mouse x, mouse y. So we had mouse x, mouse Y. I'm going to look at it and see, oh look, see. And now that actually makes it more fun when I move to the different quadrants and we see the color change versus just the color changing. It's actually more fun. So we're drawing it that way. But we could just as easily have said x is equal to mouse x, y is equal to mouse y, and left our code as it was before. So if I say x is mouse x, y is mouse y, now we run this, and we'll see the result is the same. But what I have done is I have decoupled my object from the thing that's affecting it. So now I just have my object of draw this object at x and y. Well, what is x and y? Well, we define it somewhere else in our code. And this becomes really useful if I want to have something animate. So if I want to make a ball move around on screen, or bounce, or do all kinds of other fun stuff, we can now take advantage of variables to make that happen. And that's when it gets to be a whole lot of fun. And that's what we're going to look at next. First thing we need to do is we're going to work on our moving box, which allows us to use conditionals and draw the objects and use variables as we've learned about them, is think about some of the variables we're going to want to use. So we will need to have our x and y position. And make sure you spell things correctly. Width for our object, a height for the object. Now, there's two more things that we will want to keep track of here. Is we will be tracking both the horizontal and vertical movement of our object as the afternoon progresses. So because of that, we're going to be making it move on screen. So there's two more values that we're going to need as part of this that we can just put in now. We won't code them into the program right away, but it's good to just have them because we know we need them. And we're going to need a speed x, so I need to say what it is though. It'll be a float, speed x, float, speed y. Now, if you want to add in a color, like on the previous example, we can certainly put a color in as well. So we can have a color object, and we can reference the color of our object. We can make it change color, do fun things like that. So I like to call my color C. Variable name should be long enough to make sense and make your code readable, but short enough so that while you're typing them in, you don't make typos. So it's finding a happy balance. Now, some code editors that you may work in, as you do that, they will give you an option to autocomplete. So you start typing in a variable name, and you can hit tab, it auto-completes it. Then in that type of environment, you use longer names because you don't have to type the whole thing in. But here, it's not giving us that assistance, so we might as well keep our names short and sweet. Now we're going to add in the two functions that are part of every program that you're going to write. So we'll have our setup, and then have your draw. Remembering that setup runs once. It initiates and gets everything prepared for your program to run, and draw will run is whatever the frame rate is set to, which as a default is going to be about 60 frames a second, so it's going to try and maintain that level of performance. So whatever you put in draw is going to keep repeating 60 times per second, but what's in setup will only happen once. So we usually will want to declare the size of our project. And sometimes we like to just put in a base background just so we know it's been specified. Now, a good practice is to then, inside your setup, to provide initial values for your starting variables. So you give them values so that your program will be able to do something with them. Because the quickest way to get an error in a program is to ask it to access a variable that has no value. Most languages will fail out at that point. They will give you an error and crash. Processing assumes if you don't provide a value, it assumes the value is 0. So it makes an assumption trying to make it nice for you. So we could go ahead and use these right now, but they all have 0 as their value, which, that's not a whole lot of fun, so we don't really want that. So now if I say x is equal to, I'm just going to start with my object in the middle of the screen. So I'll say x is 300, y is equal to 200. My width, I'm going to set my width equal to 50. And I'll set my height equal to 25. And set my color equal to the color. And I can use my tools up here and choose color selector if I want, or I can just choose a basic color as a beginning point. But if I wanted a nice deep red, I could see that it's 222, 2929. If I copy it, it copies the hex color, but I like the RGB color option, so I'm going to use that. So now if I run my program, absolutely nothing will happen except it will give me a big white square or rectangle for my project. But I can see that there's no error messages, it's not crashing, there's no issues going on. So that's a good place to be. And always just get stuff in, hit run, make sure it doesn't crash. I'm going to add in my fill color. And then I will draw my rectangle. Remembering that drawing a rectangle, it takes 4 values, x, y, width, and height. You specify those, so I'm now referencing them based on my variables. And if I hit run, I can see that it shows up almost in the middle of the screen, but my rectangle is drawing from its corner, so it's not in the middle. But that's okay for now. We'll address that down the road. Our rectangle shows up on screen, not pretty, well, it's not exciting yet because it's stationary, it's boring. In my setup originally, I didn't declare what speed x and speed y were yet. I forgot to do that on the first go around. So I'm going to do that now. And I'll say speed x is 5, speed y is equal to 5 as well. There's no reason they both have to be the same value. Actually, I'm going to put it down to 1 though, because it's easier for me to talk about what's going on. But animating with a speed of 1 is kind of slow. But it allows us to see it and talk about it while it's happening. So we can play with that value. Now, as I'm drawing my object and thinking about what's going on is, if I were to, inside my draw function, I'm just going to move this up a little bit here so it's easier to see. A bit higher on the screen. Just need some extra. So in my draw function, if I were to say something like speed x, or sorry, x is equal to speed x. Sorry, I'm completely botching that. I can't type. There we go. X is equal to x plus speed x. So we say x is equal to the current value of x plus speed x. So when it hits this line of code, x, which was 300, it says 300. So x is equal to 300 plus 5. So 305, or 301, because speed x is 1. And then the next time it goes through, 301 plus 1, 302 plus 1, 303 plus 1. It's easier just to see it. You can see, oh look, my box is going. Now I'm getting a black bar showing up like that because my background isn't clearing itself each frame. And that 1 pixel is the size of the margin. Now if I were to say something like 5, just so we can see, we'd see the little bars going. But my box shot off screen, and with 5 it's going kind of fast. So I'll leave it at 1 while lecturing just to make it a little bit easier to see what's going on. I'm also going to clear the background each frame so it actually looks like the box is moving instead of just leaving a trail. And to clear it, I can just say background 255. That just paints the whole background with solid white each time and run it. And now it looks like my box is going. The sad part, though, is my box hit the side of the screen and, well, it's still going. So if I could see, it's now somewhere about over here, and it's slowly working its way off. So it's still there. It's still moving. It's just outside my visible area. So we need to find a way to take care of that. But getting it moving is the first step, and that makes it a whole lot of fun, at least from my point of view. Once things start moving, everything becomes a lot more interesting. The next step is to get our very slow-moving box to not leave the screen, but to stay on screen and come back so we can see it again. To do that, we get to introduce a conditional. A conditional is where we ask the program a question, and it gives us an answer. It says yes or no, true or false. That's how the computer only knows 2 things. It knows yes, no, true, false, on, off, just that kind of Boolean logic. So we ask a question in a yes or no format, and then the computer will respond back to us and say yes or no, true or false. So we say, hey, is the X of my object off screen? And if the answer to that is yes, then we need to reverse our direction, so we start going back in the opposite way. And we will ask if, eventually we'll say, hey, if the Y of my object is off screen, reverse my movement so that I'm no longer off screen. So we're going to ask that question, am I off screen? If the answer is yes, reverse it. If not, don't do anything. That's simple. So the syntax is we say if, and then inside parentheses we ask our question, and then we'll have curly braces of now this is where we do something. So we ask our question inside there, and if something happens, then we go do something. So right now I have an error because it's waiting for me to ask something. So what I want to say is my X greater than, and in this case, has my X gone off screen? Well, there are 2 variables that are kind of program variables that are part of your project, which is width and height. The width of your sketch and the height of your sketch, those are stored. So I could actually just say width like this, and it knows that. So I don't have to, in my setup, say I want width equal to 600. I just said size is 600, and now it knows width is 600. But I could just as easily just type in 600 because that's the size of my project. Question, if my X is greater than 600, I want to make it go back in the opposite direction. So that's do something. So now I'm going to figure out what that do is. So currently I'm moving to the right because I'm adding speed X each frame. So 60 times per second, I am adding in 1 pixel, 1 pixel. 1 pixel, 1 pixel. So every second I move 60 pixels, which is why it's kind of slow. It's like for 1 second I don't even move the width of my object, or I move about the width of my object. So it's like, yeah, that's kind of slow. But when I hit that side, I want speed X to reverse itself. So it's not 1, it becomes -1. So I could use another conditional, and this would be a hugely inefficient way of doing it. And I'm going to type it in just so you can see how bad it is, and then show you a much better way and the preferred way of doing it. So I could say if speed X is equal to 1, then speed X, so you don't want to do it this way. I'm just telling you, so don't even type this. This is horrible, but this is how we can do it. So if speed x is equal to 1, set speed x equal to -1. Else if speed x is equal to -1, speed x is equal to 1. All of this, we're going to instead just say speed x times equal -1.
Does this in the do something?
Which speed x times equal -1 is the same as speed. I'm just going to write a comment after it so we can see that is equal to speed x times -1. And what this does is if we take any number and multiply it by -1, it takes the positive or negative sign and flips it. Because if you take a negative number and multiply it by -1, it becomes positive. A positive number by -1, it becomes negative. So speed x started at 1, a positive number. Multiply it by -1. Boom, it's now negative. We start going back the other way. Then we're going to have to check and find out, hey, did I hit the other side of the screen, 0? And when that happens, boom, we multiply it by -1, so that negative becomes a positive, and we start going back. So then we create the bouncing pong, and it's really, kind of fun at that point. Now, I'm going to just comment out the part that is the ugly way of doing it, and leave it there just as a reminder if that's how I don't want to do things. Now, on this line I'm going to actually just put both of these on 2 lines here. Speed x times equal -1 is a shorthand way of writing speed x is equal to speed x times -1.
You gotta reverse it. Yeah.
So I reverse it and then I reversed it. So if I did this, nothing changed because I'm doing it twice. But I'm showing you 2 ways of writing the same thing. So we're going to go with the shortest possible way. I'm going to just put this line of code here, comment that out, put it up here as well. So to reverse the speed, if x is greater than 600, speed x times equals -1. So that now reverses my speed x. If I run this, we will see when my box hits the edge, comes back. Okay, well, when its x point hits the edge, you can notice the whole box went off screen, so we'll have to tweak that a little bit. Oh, wait. Oh, it's gone. So now we have to fix that. Then we'll worry about the fine tuning so it doesn't go all the way off screen as well. So to do that, to take care of the left edge, we could do another if statement and say if x is less than 0. But we don't have to because what we really want is if x is greater than 600 or if x is less than 0, reverse it. So we can do what's called a compound statement. So we can use the word or in our thinking, but we can't type the word or. We have to use a programming way of representing the word or. So we're going to say or x is less than 0. Now, the way that we represent the word or in a conditional is with the character on the keyboard called the pipe. So we do 2 vertical pipes. And that is the key directly above the return key. So we do 2 pipes, and that gives you, that's the programmer representation of the word or. So this is now saying if x is greater than 600 or if x is less than 0, flip my speed so it now starts bouncing. And we'll see it goes all the way over to that side. And now that I have margins going on here, I might increase my speed because this is painful to watch. It's kind of slow. It's pokey. It's fun to talk about because it goes on forever. Boom, it hit the side and bounced off. All right. So we can see that that's working. And this is where now I'll just change it to, we'll just do 5 so we can see it now run. And now it becomes much, it's bouncing, but it's still going too far to the right. But if we think about it, we said if it's greater than 600, well, 600's all the way over, but it's going too far over by a certain amount, and that amount happens to be far by W. I can just say 600 minus W. And that will say that, because that way, while I'm writing this question, asking this question, I don't have to remember how big is my box anyway. I honestly don't remember because I changed the number in my head a bunch of times before I typed it in. I'm going to just clean my code and get rid of the things now that we've stared at it long enough, the ugly way of doing things. Now we just have it clean. Now, one thing when you are working periodically, you may end up with things that they're spaced out funny. You can't tell which curly bracket goes with what, and it's a mess. If you look under that pull-down menu, you see there's an option called Autoformat, and you hit that, and it cleans up the indents and spacing of everything on your code. That's a really nice thing when you are typing things, not really sure, or you can't tell what's inside what curly brace, what goes with what. If I put my cursor on a curly brace, you will notice that it highlights its mate. And that's a really useful way to go, okay, what does this go to? Because as our programs get more complex, we're going to run into situations where we will have curly braces nested in curly braces and curly braces and curly braces. And if your indenting's all screwed up, it becomes really hard to figure it out. You can auto format, and sometimes it will fail because you have an error. So you have to start matching curly. So you click on one and it lines up and it says, I think this is my mate. And if you go, no, that's not right, then you know that's part of your problem. So we'll use that as a troubleshooting thing.
How'd you find that?
I've cleaned my code. I'm going to add in my y's for it as well. So we have my x's, change x's to y, and then I will make a version here. So x becomes y, w becomes h, x becomes y, x becomes y. But my 600 is off here because 600 is not the size, but it's 400 tall. And since y is about my vertical dimension, I need to fix it to 400. So now if I have done this, I'll just enter in a 5 there as well, hit run. We'll see where it now bounces around on screen Pong style. And it will just keep bouncing forever because now my code is set up to loop perpetually. Now we've succeeded in successfully getting an object to animate on screen, moving on both the x and the y axis. But right now it's just a simple rectangle. But if I wanted to, say, put something, like maybe add some eyes and a mouth to this rectangle, I'm going to make my rectangle bigger so it's easier to work with. And that shouldn't be too bad to do because I just change its width and height, and the rest of my code is still going to function because down in my draw, I only referenced width and height. I didn't reference the actual numbers. So that's part of why we always want to use variables. But my red box needs some eyeballs on here, so I'm going to draw some ellipses. So if I think about my box is 100 across, and I want to put 2 eyes in there. So if I put one eye in 25 and one eye in 25 from the other side at 75, I can draw little eyeballs there. And I'll just fill them with white for now. You can always give it some other color if I get so motivated. And then draw in my eyes. So if I say ellipse, and now the location of where to draw this is we're going to start from wherever the x is, and we're going to add to it. In this case, I'm going to add 25. And then I will bring the eyes down maybe 10. So y plus, no, actually I'm going to bring them down 20. And we'll see why in a moment. And then we will make the eyes 20. So right now that draws one eyeball. And if we verify that works, then we can go and draw the other eyeball. So if I run this, we'll see, all right, now I have one eye, or a hole, in my object. To add a second eye, it's going to be just like this first one. But instead of going 25 over, I will want to go 75 over. So it puts it closer to the other side, and the rest of it will be the same. This would have been a fantastic use of copy-paste, so it would have been less typing, but it still works. Now we can see he's got a couple eyes. Now if I want to add more to my box, I could give him a mouth, I could give him more body, and keep going till he gets arms and legs, feet, a hat, or hair, or whatever else you want to put onto it.